So now we have our digital output pins for the motor, and we have our PWM set up. But after looking at the data sheet for the PWM, it turns out then when this PWM is in reset, these outputs are zeros. And so that's going to drive the ENA pin and the ENB pin to 0. And no matter what we do with these, that means the motors won't turn. So let's just force the PWM outputs to a logic 1, and then that will allow us to test forward, out, reverse, left, right, and so on. And then later on we can come back in and reinsert the PWM. So I'm going to select the whole PWM here and slide it this way. These digital outputs here, and break them off from the PWM. And let's put them back up here. Now, one thing I could do is I could just force a logic 1 on here, but eventually we do want to try to use the PWMs. So I think what I'd like to do is use what's called a logic OR gate. And so let's go find an OR gate. And there's one right there. And if you don't remember how OR gates work, let's see if they have a truth table here. Here we go. A truth table for a logic OR gate. So anytime both inputs are 0, the output is a 0. Anytime one or both of the inputs are a 1, the output is a 1. So what we can do is we can use an OR gate to force the outputs to be 1. And I'll show you how to do that. So we're going to drag an OR gate here, excuse me, and another one here. And we'll hook the PWM to one input on the OR gate. And I'm pressing the W key, which puts me in wiring mode. And the other input on the OR gate. So now how do we get the PWM signal to come through here? We put a logic 0 on these inputs, and then anytime the PWM is a high, it will be high. Anytime the PWM is a low, it will be low. And so what happens if we put a logic 1 on these inputs? Then this output will stay logic 1 no matter what the PWM signal does. So let's go find our logic 1, or logic high. And let's wire this to here. And let's wire this to here. And now these PWM outputs will be logic 1, and that will enable both PWM, both steering and drive motors. And I think there are a few other things we need to do here. Let's copy. Whoops. Let's copy this it's logic 1, Control C, Control V. And let's force the PWM into reset. And for the time being, let's put a clock on the PWM. I'm double clicking on the clock, and we'll just change it to 1 megahertz right now, which gives us a 1 microsecond resolution. If you recall, the PWM pulse is a pulse between about 1 microsecond and 250 microseconds. So for an 8-bit timer, that'll give us exactly what we need. And then, so now we've basically disabled the PWM, but it's in the circuit, so we'll be able to see how well the PSoC design software deals with wiring it up. And then let's do one more thing. Control C, Control V. And let's put a 1 on the forward out. Now that will cause the motors to drive forward. So this will turn on the H-bridge controller channel that drives the motor forward.